Welcome everyone to Microsoft Ignite. Those who are joining us online, hi. Welcome to our developer session of how Visual Studio build Visual Studio with Visual Studio. I'm Fatma Ijaz. I am the Group Engineering Manager for Visual Studio Engineering team. I have been working with Microsoft for almost 10 years. Mostly my background is in cloud and services. I have experience of working in Azure, Bing team, and welcome here. Mark?
Hi, my name's Mark Osborne. I'm a principal software engineer in the Visual Studio engineering team, and I've been working on improving the engineering system for our developers for about 15 years now.
Great, thank you, Mark. Most of you are familiar with Visual Studio as an IDE. It is a mature product with rich set of features. But today in our session, we will go behind the scene and look at how Visual Studio developers build Visual Studio itself. Before I jump into that, I want to highlight a few aspects of Visual Studio that brings challenges for its engineering system. Visual Studio has a very large code base that is developed over 25 years, and it has it includes its core components like shell, editor, debugger, the client and UI. It also supports multiple languages, including Python, C++, and C#. And another trick that comes in for its engineering system was that it also serves as a vehicle to serve different technology constructs and support their IDE features as it ships. Next slide, Mark. Around the same time when Satya became the CEO, we started with the effort of revamping our engineering system. We started with two goals, faster shipping, cadence, and as well as cloud first. Why we needed faster shipping was that we realized that we need to respond to the needs of our customers, which were moving fast as the technology was rapidly changing. So we felt like they were tied to our shipping schedule, and we were not able to deliver constructs and IDE features to them fast enough. That was the first goal we started with. But around the same time, we realized that it will be a good time for us to move to a cloud-first engineering system. Why? Because we wanted to leverage the scalability and the flexibility we get from the cloud to effectively control our cost. Otherwise, we were tied with an on-prem infrastructure which had dev and test labs. So we started with these two goals and aligned it with our developer productivity goal, which was always the highlight for us. Next. So before we jump into what the new engineering system looks like, let's learn from Mark, what were the challenges in the previous engineering system that was on-prem?
Sure, so let's talk about what it used to be like. So the first thing you have to do is get source code onto your machine, obviously. But we had a TFS repo, which was, by the time you downloaded the files onto your machine, it was about 255 gigabytes. So you really didn't want to download all of that onto your machine. So you would just download the partitions that you needed to change code in, and you would just build those partitions.
So what is a partial build?
Yeah, so what we did is we split the code up into multiple chunks. So we'd have, a chunk for VB, a chunk for C#, and we actually checked in binaries from previous builds so that we could build one of those chunks independently, so developers could actually get work done on their machine.
Great. So let's say, Mark, I'm a developer in that engineering system. I have enlisted this partial partition, and then I have figured out which partition I have to go to build it. So I want to test my changes once I make them.
Yeah, so the first thing you want to do is test those changes locally. And you could just sort of build your code changes, take those binaries, and copy them over an existing version of Visual Studio. But we didn't support side-by-side back then. So you would typically have a second dev machine with Visual Studio installed on it, which you would use as a test machine, and you would copy your binaries across to that machine.
Okay, so that means as a developer, I have to maintain two machines, one a developer machine and then a test machine to make my changes.
Yep.
Okay, so let's say I have tested locally. What about checking in?
So you would submit your changes to a team validation server, and because our build took so long, we used to have sort of per team servers which would just build those partitions that team most frequently made changes in, and maybe it would run a few tests. And then if you were successful, it would check those changes into TFS.
Okay, so let's say I have submitted it to this validation server, and I'm ready to check in, and I have checked it in. Are my changes available in Visual Studio now?
They're in the branch, and they would be picked up by the nightly build. And the nightly build would take about 8 hours to run if there wasn't any build breaks.
Oh, how long this nightly build takes? Like 8 hours?
Yep.
Wow. Okay. So what happens if a build break occurs?
Yeah, so we actually had dedicated engineers, BFDs, build facilitated devs, and what they would do is they would analyze the build breaks, and then they would assign issues for developers to sort of fix as fast as possible to unblock the branch.
Okay, great. So let's say my nightly build passes, and now is it ready for me to test out in the Visual Studio?
Yeah, but what would happen after the nightly build finished is it would trigger a set of tests. So we would have build verification tests. And if one of those broke, then an issue would be assigned to you. And then, over the next several weeks, scheduled test runs would be kicked off. And again, that could find a bug in your code, and you could be assigned an issue to fix.
Okay, that's interesting. So you're telling me that I have checked it in, there was a nightly build. Now, after a few weeks, there will be tests that will be run, and I will know if I have introduced a bug.
Yeah, and typically developers had a backlog of bugs to go fix on features that they, finished working with weeks ago. And we actually had this thing called bug jail, which was if a developer had too many bugs, they had to stop working on their new features and go fix bugs on the old features.
Okay, so it seems a little challenging that I have testing so much distributed and has a lot of latency. How do you keep these tests passing all the time?
Yeah, so actually it was very difficult to keep the tests running. This latency with both the build and the tests caused real problems. And we even had this thing called test analysis, where because test runs, rarely passed, an engineer would analyze the results from a test run. They'd work out which bugs were going to, be ship blocking, which bugs we'd actually seen before and we'd already filed an issue for, the duplicates, and which were just flaky tests and the tests needed to be fixed.
Okay, so let's assume that was my lucky day, maybe lucky weeks, because it takes weeks. But I was able to build it, test it, and everything looks good. So now, what was the story about dogfooding?
Yeah, so dogfooding is basically Visual Studio developers using the Visual Studio product to develop and build their code so that we could find issues before customers did.
Okay, so what about customer feedback?
We would generally do an RC, 2 RCs, release candidates, about 4 months apart before we released the product. And that's where we got the majority of our customer feedback.
Okay, so let's say we received customer feedback, we are done with the dogfooding, I'm ready to ship. What the release looks like?
Yeah, so then we have to do our final build. So we have to not only build the product, we also have to build it for all of the languages, we have to sign it, and we have to upload it to the Microsoft Download Center.
Okay, so it looks like a very lengthy process. So how long was this release taking?
Well, it could take as much as 3 weeks in the worst case.
What? After I have done everything and I'm ready to give it to my customers, I have to wait extra 3 weeks?
Yeah. So the problem here was that we had everything in the same repo. We had a big Mondo repo. So we had Visual Studio, we had .NET, they're all checked in the same repo. So we actually had to build .NET and Visual Studio together, then take the .NET bits, and we would check those into Windows, and we'd do a Windows build, so that we could send that off to the Windows packaging lab so that they could get official signed bits, which we could install on Windows. We then take those, check them back into the Visual Studio build, rebuild Visual Studio all over again, localize it, sign it, and then send it to the download center. So with, 6 builds, 4 different build labs, multiple handoffs, it can take 3 weeks to get through that process.
Okay, it seems like a very coupled and a lengthy process. So how often were you shipping Visual Studio?
So at that time, we were shipping about one release every 2 years, and then we would do updates about 4 months apart.
Okay, cool. So now that I understand what the background and the challenges of the old engineering system was, how about, Mark, we talk about starting from the enlistment, how things improved?
Okay, so the first problem that we had to solve was that monorepo, that 255 gigabytes, because that was causing us a lot of problem. So what we wanted to do was take that and shrink it down to a 1 gigabyte Git repo.
1 gigabyte, 255 to 1 gigabyte.
Yep.
How would you do that?
Well, we did that through componentization. So we looked for areas of the code which were decoupled enough that we could take them out of the monorepo and put them in their own repo. And then most of those would have their own Git repo. They would build and test in Azure DevOps and then insert back into the Visual Studio repo. For a few larger components like .NET, they had their own dedicated build system. And then all of those binaries that we had, we sort of had to suck those out of the repo because Git doesn't really like binaries. And the process then was each of these components would do an insertion into the VS repo, but all they were really inserting was a package ID. So we used NuGet packages mostly, and we could just take a package reference to that in the code, and then we would update the NuGet central package versioning version number during that insertion. And then we also have, especially for Visual Studio, we have setup packages, which is where the Visual Studio installer can consume those packages directly. But again, all you're checking in to the Visual Studio code base is just a reference to that package.
Okay, great. So it was an intelligent use of NuGet and central packaging version. Great. So now that I have a smaller repo to enlist, what about the build? How will you improve build for me?
Yeah, so it's still, there's still a lot of source code there. It still took a lot of time to build that. So what we did is something that a number of companies with large repos have done, and Microsoft has lots of large repos. So Microsoft invested in a distributed build system, which we call Cloud Build. And the way that works is Cloud Build would do the NuGet restore to download all of the packages, and then would call MS Build to generate a build graph. So this is the order in which the projects would be built. And then those individual projects are sent off to be built on VMs independently. So we would build the project, and we would save the outputs of that project and put it into a cache. And then the next project in the chain would download the outputs from the previous project, and then we'd sort of traverse the graph that way.
So what is this hash match that you have mentioned?
Oh, yeah. So at the beginning of that process, we calculate the input hash of a project. And so that's all of the files that it's consuming. If that input hash already has a match in the cache, we don't even need to build the project. We can download the outputs from a previous build of the project. So we can have subsequent builds of the Visual Studio repo. They don't build every project. They only build the ones which are impacted by the commits that people check in.
Okay.